Welcome to sixth grade math. Vocabulary review, factor, numbers multiplied together to get a product, prime number, a whole number that has exactly two unique factors, one in the number itself, composite number, a number greater than one with more than two factors, prime factorization, expressing composite numbers as a product of prime numbers, base, the number used as a factor, exponent, indicates how many times a base is used as a factor, how many times a base factor is multiplied times itself. Exponent indicates how many times the base is used as a factor. Get ready for the lesson. The Venn diagram shows which activities each camper participated in on Monday. So Venn diagrams use overlapping circles to show common elements. So in this case, who participated in swimming only? Tyler and Sonia. Who participated in crafts only? Savannah, Lewis, and Miko. And then who participated in both swimming and crafts? Owen and Isabel. So the common factors are the factors that are shared by two or more numbers. So in this case, if these were numbers, Owen and Isabel would be the common things. They did both swimming and crafts. Greatest common factor, or GCF. The greatest common factors of two or more numbers. So the common factor is that is the largest number. Identify common factors. Identify the common factors of 16 and 24. So we need to list all the factors. Factors of 16 and the factors of 24. So 1 times 16, 2 times 8, and 4 times 4. So the factors of 24 are 1 times 24, 2 times 12, 3 times 8, 4 times 6. Circle the common factors. So we have 1 common to both. We have 2 common to both. 8's common to both. And 4 is common to both. So the common factors are 1, 2, 4, and 8. And if we do a Venn diagram, we can see that. Well, all we did was take the factors from the tables on the left and put them into this diagram. Identify common factors. So common factors of 25 and 60. List the factors by pairs for each number. So factors of 25 are 1 and 25, and 5 times 5. Factors of 60 are 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, or 6 times 10. So let's circle the common factors. We have 1 and 5. So the common factors are 1 and 5. So if we made a Venn diagram of these two numbers, the factors of these two numbers, that's what it would look like. 60 has a lot of factors. And notice that there's a 5 for 25 inside the common area for both factors, and then there's one outside because there's 2 5s in the factors. So we have to list it both times, but only one is common to both numbers. Identify the common factors of 18, 27, and 36. So first, list the prime factors for each pair of number, for each number. So this time we're going to have 3 tables, and we have 1 times 18, 2 times 9, and 3 times 6. Factors of 27, 1 times 27, 3 times 9, The factors of 36 are 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Let's circle the common factors. So 1 is common to all of them, 3 is common to all of them, and 9 is common to all. So the common factors are 1, 3, and 9. And if we have now a Venn diagram with 3, notice there's a couple ways this overlaps. There's one in the middle where all 3 circles overlap. Then the pink and the blue overlap by themselves, the yellow and the pink, and the blue and the yellow. So there's actually 4 ways that numbers can be common to other numbers. So the 1, 3, and 9 we know are common to all 3. 27 doesn't have any other common factors with any other number. So we can just put 27 in by itself. And then 2, 6, and 18 are common factors of 18 and 36. So we're going to put those where the blue and the yellow overlap. And then that leaves 36 with 4 factors. And scaffolding questions, common. What do the numbers 2 and 4 have in common? They're both even. They're both less than 5. They're both greater than 1. What are the factors of both numbers? 2 is 1 times 2. 4 is 1 times 4 and 2 times 2. What factors do 2 and 4 have in common? Well, 1 and 2. So 1 and 2. Find a GCF by listing factors. Find the GCF of 60 and 54. First, make an organized list of the factors for each number. So 60, we have 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. So if we just rearrange those and list those out instead of by multiplying, that's what it looks like. 54, 1 times 54, 2 times 27, 3 times 18, 6 times 9. And if we just rearrange those in order from least to greatest, that's what that looks like. And now we're going to circle the common factors, and that's why we listed them out in that order. So 1, 2, 3, 6. So the common factors of 54 and 60 are 1, 2, 3, and 6. And the greatest common factor is 6, because that's the biggest common factor. Use a Venn diagram to show the factors. So there's the Venn diagram, and there's the common factors, and there's the factors of 60, and there's the factors of 54 only. The GCF of 54 and 60 is 6. Find the GCF of each set of numbers, so 35 and 60. 35 is 1 times 35, 5 times 7. And if we just list those 4 factors in order from least to greatest, it'll make it easier on us in a minute. So 60, we have 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. We're going to organize those from least to greatest. And now we're going to circle common factors, which is 1 and 5. So the greatest common factor of 35 and 60 is 5. D, 15 and 45. If you look at that, you might have a guess already as what the greatest common factor is. Let's see if you're right. 1 times 15, 3 times 5. So we have 1, 3, 5, and 15 for 45. 1 times 45, 3 times 15, 5 times 9. And if we list those out, and then if we circle the common factors, we have 1, 3, and 5, and we also have 15. So the greatest common factor of 15 and 45 is 15. 12 and 19. So 12 is 1 times 12, 2 times 6, 3 times 4. And we'll list those factors from least to greatest. And 19 is 1 times 19. So those are the only two factors of 19 because 19 is prime. And that makes, if we circle the common factors, the greatest common factor of 12 and 19 is 1. Factors, common factors, factors that are shared by two or more numbers. And greatest common factor, the greatest of the common factors of two or more numbers. So the common factor that is the largest number. The first step in finding the GCF is to find all the common factors of two or more numbers. All numbers have the numbers 1 as a common factor. GCF can be found by listing all factors, like in the last example, or by using prime factors. In prime factorization, the common prime factors are used to find the GCF. So 36, if we do a factor tree, there's 6 times 6, and we can do 2 times 3, and then we can factor 6, 2 times 3, and the prime factors of 36 are 2 times 2 times 3 times 3. So notice this time we're not listing 1 times 36 and 2 times 18. We're just listing the prime factors. The prime factors are 48, 6 times 8. If we factor 6, we get 2 times 3. And if we factor 8, we get 2 times 4. 2 times 2 for 4. So there's our prime factors of 48. 2 times 2 times 2 times 2 times 3. So find the common prime factors. So we'll circle, there's a 2 in common, there's a second 2 in common, and then there's a 3 in common. So the GCF of 36 and 48 is 2 times 2 times 3, or if we find the product of that, it's 12. So the greatest common factor of 36 and 48 is 12. Find the GCF by using prime factors. So find the GCF of 18 and 30. We're going to, method 1, we're going to write the prime factorization. So 18 is 2 times 9. And then we'll bring the 2 down, and then the factors of 9 are 3 times 3. So 30 is 2 times 15. Bring the 2 down, we'll factor 15, 3 times 5. So we have a 2 in common, we have a 3 in common, so 2 and 3 are common factors. And then if we do divide by prime numbers, 18 and 30 both divide by 2. So 18 divided by 2 and 30 divided by 2. 18 divided by 2 is 9. 30 divided by 2 is 15. So then if we divide both of those quotients by 3, we get 9 divided by 3 is 3. 15 divided by 3 is 5. And because that's as far as we can go, 2 and 3 are the common factors. And using either method, the common factors are 2 and 3. So the GCF of 18 and 30 is 2 times 3, or 6. Find the GCF of 12 and 66. If we factor 2 times 6, bring 2 down, then we factor 6, 2 times 3. And then we need to find the prime factors of 66. So we have 2 times 33, bring 2 down, 3 times 11, and the common factors are 2 and 3. And if we do divide by prime numbers, we have 12 and 66. We're going to divide each by 2. So 12 divided by 2 is 6. 66 divided by 2 is 33. And we can divide both of those by 3. So that's what we'll do. 6 divided by 3 is 2. And 33 divided by 3 is 11. And we'll just use what we divided by. 2 and 3 are common factors. So using this method, the common prime factors are 2 and 3, and the GCF of 12 and 66 is 2 times 3, or 6. Find the GCF using prime factors. So find the GCF of 36 and 45. Write the prime factorization. 36 is 6 times 6. We'll factor 6 into 2 times 3. The other 6 into 2 times 3. And then 45 is 5 times 9. Bring the 5 down. 9 can be factored into 3 times 3. And if we find the common factors, it's 3 times 3. And the divide by prime numbers, we'll divide 36 and 45 by 3. So 36 divided by 3 is 12. 45 divided by 3 is 15. And we can divide both of those by 3 again. 12 divided by 3 is 4. 15 divided by 3 is 5. So our prime factors or common factors are 3 and 3. So using either method, the common prime factors are 3 and 3. So the GCF of 36 and 45 is 3 times 3, or 9. Find the GCF using prime factors. Find the GCF of 32 and 48. Method 1, we're going to factor out 32, 4 times 8. Factor 4, 2 times 2. Then we'll factor 8, 2 times 4. We'll bring the 2's down. Then we'll factor 4. So we have a whole lot of 2's there. 48, if we factor that, it's 6 times 8. Factor the 6. Factor the 8. We'll bring down the 2, 3, 2. Factor the 4. And now we'll look at common factors. So if we circle them, it helps sort out how many 2's there really are common to both. Looks like there's 4. So 2 to the 4th are common factors. Divide by prime numbers. So we'll divide 32 and 48 both by 2. So 32 divided by 2 is 16. 48 divided by 2 is 24. We can divide by 2 again. 16 divided by 2 is 8. 24 divided by 2 is 12. We can divide by 2 again. 8 divided by 2 is 4. 12 divided by 2 is 6. Hopefully you recognize those are even numbers, so we can divide by 2 one more time. 4 divided by 2 is 2. 6 divided by 2 is 3. And if we circle all of those, we're going to end up with 2 times 2 times 2 times 2, or 2 to the 4th power is common factors. And if we multiply that out, the GCF of 32 and 48 is 16. Real world examples: a bakery arranges 3 different types of muffins in a display case. There should be an equal number of muffins in each row in the case. What is the greatest number of muffins in a row? So we have 40, 24, and 32. So what do we need to find? The GCF, right? Greatest common factor. And the factors of 40. There's the factors of 24. And the factors of 32. So if we circle the common factors, we get 1, 2, 4, and 8. So the greatest common factor is 8. So the greatest number of muffins that can be on each row is 8. How many rows of muffins are there if there are 8 in each row? So there's a total of 40 plus 24 plus 32. So if we add that up, 96 muffins. So the number of rows of muffins is 96 divided by 8, or 12. Check your progress. Jerica makes and sells beaded necklaces. She earns $49 on Friday, $42 on Saturday, and $21 on Sunday, selling necklaces at a local crafts sale. If Jerica sold each necklace for the same amount, what is the most she could have charged per necklace? Hopefully you see that we need to find the greatest common factor, and we'll use prime factorization. And do you see a pattern in the numbers? 49, 42, and 21. Do you recognize what factor might be for all those from your times tables? Multiples of 7. So 49, 7 times 7. So that's it. 42, We have 7 times 6, so we bring the 7 down, we'll factor the 6. And then 21, 7 times 3, and we'll just bring those down so we're all in a line. And if you look at that, there you go. GCF is 7. So the most she could charge per necklace is $7. And how many necklaces did she sell? Well, we know she sold $49 one day, $42 the next, $21 the next. So she sold $112 worth of necklaces. And if she charged $7 each, she sold 16 necklaces. Additional examples, identify the common factors of 20 and 36. So for 20, 1 times 20, 2 times 10, 4 times 5. So we're going to list those out, least to greatest. For 36, 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. So if we list those out in order from least to greatest, and if we circle the common factors, we end up with common factors 1, 2, and 4. And number 2, find the GCF of 36 and 48. Use prime factorization. So for 36, we get 6 times 6. Factor the 6 out, factor the other 6 out, and we get 2 times 2, 2 times 3 times 2 times 3. For 48, we're going to do 6 times 8, factor the 6, we'll factor the 8, bring those down, then we'll factor the 4, and now we'll circle the common factors. And the GCF of 36 and 48 is 2 times 2 times 3, or 12. And if we find the greatest common factor of 52 and 78, we'll divide by prime numbers. So they're both even. We can divide those by 2. 52 divided by 2 is 26. 78 divided by 2 is 39. And if we divide each quotient by 13, 26 divided by 13 is 2. 39 divided by 13 is 3. So the GCF of 52 and 78 is 2 times 13, or 26. Anna sells bags of different cookies. She made $27 selling bags of peanut butter cookies, $18 from selling chocolate chip cookies, and $45 selling bags of oatmeal cookies. Each bag of cookies costs the same amount. What is the most that Anna can charge for each bag of cookies? And hopefully you know we need to use the greatest common factor. And do you see a pattern in the numbers 27, 18, and 45? Think back to your multiplication tables. Those are all multiples of 9. So is it possible that the greatest common factor is 9? Yep, we'll divide. So if we have 27, 18, and 45, if we divide all 3 by 3, because remember we're going to divide by prime numbers, so 27 divided by 3 is 9, 18 divided by 3 is 6, 45 divided by 3 is 15, you can divide by 3 again, 9 divided by 3 is 3, 6 divided by 3 is 2, 15 divided by 3 is 5, and we have 3 times 3, so that is going to be 9. And how many bags of cookies did she sell? So if you add up all those amounts, you get $90 worth, and if you divide by $9, you get 10 bags of cookies. There's your homework. Head on over to Google Classrooms, and have a great day.